for light years. That's all that separates us from our closest neighboring star system, Alpha Centauri. And now, thanks to the James Webb Space Telescope, astronomers believe they may have spotted something extraordinary orbiting one of those stars. A brand new exoplanet, hiding in plain sight, practically right next door. Today, we'll explore what the James Webb saw, why this discovery could rewrite what we know about nearby star systems, and how it could ignite the next chapter in humanity's journey to the stars. The James Webb Space Telescope, or JWST, has done it again. Using its mid-infrared instrument, also known as MIRI, the telescope captured unprecedented images of the Alpha Centauri system, our cosmic neighbor made up of Alpha Centauri A, Alpha Centauri B, and the distant red dwarf Proxima Centauri, an orbiting Alpha Centauri A, a star remarkably similar to our Sun in both age and temperature. Webb may have found a planetary candidate. Here's the catch: this object is 10,000 times fainter than its host star. That's like spotting a firefly buzzing next to a stadium floodlight from miles away. But JWST pulled it off using a coronographic mask, a specialized tool that blocks the star's blinding light, revealing faint objects hidden nearby. So what did Webb actually see? A faint, moving dot that could be a gas giant, a massive planet several times larger than Earth, orbiting Alpha Centauri A at about 2 astronomical units from its star. That's roughly twice the distance between Earth and the Sun. And here's where it gets exciting. This gas giant is sitting inside the star's habitable zone. The habitable zone is a region around a star where temperatures are just right for liquid water to exist on a planet's surface, a key ingredient for life as we know it. Now, before you start packing your bags for an interstellar move, remember, this candidate is a gas giant, not a rocky Earth-like world. It doesn't have a solid surface to walk on, but that doesn't mean the story ends there. Gas giants can host moons, and some of those moons could be rocky, icy, and potentially capable of supporting life. Just think of Jupiter's Europa, or Saturn's Enceladus in our own solar system, worlds with oceans hidden beneath their icy crusts. If this exoplanet has moons like those, orbiting inside Alpha Centauri's habitable zone, well, that's where things get truly intriguing. As exciting as this sounds, astronomers aren't popping champagne just yet. Subsequent JWST observations haven't been able to confirm the planet's existence. It's possible that the object was too close to its host star during follow-up imaging, making it impossible to detect a second time. Computer simulations back up this possibility, showing that if the planet's orbit brought it to near Alpha Centauri A, the glare might have completely hidden it from view. So right now, this potential planet remains a candidate, not a confirmed exoplanet. That's where the Nancy Grace Roman Space Telescope comes in. Scheduled to launch in 2027, the Roman telescope will have powerful capabilities for direct imaging of exoplanets. It might be the instrument that finally answers the question: is there really a gas giant orbiting Alpha Centauri A? You might be wondering, why is this such a big deal? Especially if the planet is just a gas giant. The answer lies in proximity and similarity. At just 4 light years away, Alpha Centauri is our closest stellar neighbor. It's close enough that, with future propulsion technology, humanity could potentially send robotic probes there within a human lifetime. And Alpha Centauri A is a Sun-like star, meaning it shares similar conditions to our own solar system's birth environment. Studying planets around such a star could give us critical clues about how our own planetary system formed and evolved. Imagine this: if we can image and study a planet in detail around a star just 4 light years away, it becomes a test case for understanding thousands of more distant exoplanets we've discovered over the past few decades. And because it's in the habitable zone, it challenges us to think not just about planets, but also about habitable moons, an area of astrobiology that's only just beginning to be explored. It's no surprise this news has sparked the imaginations of science fiction fans. Alpha Centauri has long been a staple in sci-fi stories, From Avatar's lush moon Pandora to countless novels about interstellar exploration, the idea of a gas giant, maybe with moons, orbiting Alpha Centauri A feels like a page ripped straight from those stories. And that's the beauty of discoveries like this. They blur the line between science and imagination. They remind us that the universe is far from empty. It's teeming with possibilities we've only begun to glimpse. This discovery wouldn't have been possible without some serious technological wizardry. The mid-infrared instrument on JWST is designed to detect heat signatures in space, perfect for spotting planets that are faint and cool compared to their blazing host stars. But even with a MIRI sensitivity, the brightness of Alpha Centauri would normally overwhelm the camera. That's where the coronagraph comes in, a device that acts like putting your hand up to block the sun's glare so you can see something faint nearby. By masking out the star's light, JWST could spot an object billions of times fainter than the star itself. That's an observational feat that was nearly impossible with earlier telescopes. If the planet is confirmed, the next step will be to study it in greater detail, its mass, atmosphere, and whether it has a system of moons. This is where next-generation telescopes will shine, including the Roman Space Telescope, ESA's aerial mission, and eventually, even more advanced instruments that could directly image exoplanets in incredible detail. And maybe, just maybe, in the far future, we could send an actual spacecraft to the Alpha Centauri system. NASA's breakthrough Starshot concept imagines using light sails to push tiny probes to 20% the speed of light, reaching Alpha Centauri in just over 20 years. Whether this planet turns out to be real or just a cosmic mirage, the search itself is pushing the limits of what humanity can see, know, and imagine. For light years away, a world might be waiting for us. And if we've learned anything from the James Webb Space Telescope, it's that the universe always has more surprises in store. Thanks for watching Dynamic Trends. If you enjoyed this video and want to stay up to date with the latest discoveries, news, and trends from around the world, make sure to hit that subscribe button and turn on notifications so you never miss an upload. And don't forget, check out the link in the description for 10 amazing Amazon products we've picked just for you.